Okay, good morning, grade sixes. For tomorrow's test, you need to know all about pie charts. So let me just refresh your memory and just explain it to you again so that you understand it. So when they give you a pie chart like this, the first thing that you need to do before you read any questions, you have to go and check in how many pieces did they divide that pie. So if I look at this, I'm going to count it like this. That part, that's one piece. So if I had to cut this cake into pieces like this, how many pieces can I get? So I do it like this. I count. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops, 12. So I know that over here it's one whole pie, one whole. But I have 12 parts out of 12 parts of that pie gives me one pie. Okay, now, how many of these kids liked chocolate? Then I just count. Now, the question they are going to ask, they will say, what fraction? If they say what fraction and I underline it like that, then that means you've got to write down a fraction. This is a fraction. One number at the top, a numerator and a denominator. So what fraction of these kids liked chocolate? Then I count. That's 1, 2, 3, 4, 5, 6. 6 out of 12. That is the fraction of the kids that liked chocolate. But you need to simplify your fraction. So if you wrote that and you left it like that, you would only get 1 mark. You need to simplify this. Divided by 6, divided by 6, 6 divided by 6, 1. 12 divided by 6, 2. So you can see that half of the kids liked chocolate. You can see that's 50% of the kids. They liked chocolate. Next question, they could ask you, how many kids chose bread, chips, apples together? They chose bread and chips and apples together. So it's that plus that plus that. But now they say, how many kids? They are not asking you for the fraction. They are asking you how many kids chose this. So we need to go and read again. 18 kids chose chocolate as their favorite. So this part, which constitutes 50% of my pie chart, is equals to 18 kids. 18 of them liked chocolate. So how many of them liked bread plus chips plus apples? Do you see that that is also 50%? So that will be exactly the same as that. Altogether, 18 kids chose bread and chips and apples. So let me ask you another question. If this is 18, if 18 kids fit in here, in this part, and how many parts do I have here? 1, 2, 3, 4, 5, 6. There's 6 parts. I'm just going to divide this up so that you can see. If I had to spread the 18 kids out, and I had to make them stand on these slices of pie, how many would stand? It's 18 divided by 1, 2, 3, 4, 5, 6. I would have 3 kids standing there, 3 kids standing there, 3 kids would be standing there, 3 would be standing there, 3 would be there, 3 would be there. So this part of the chart actually shows me how many kids are represented by each slice. So one slice, 3 kids. Now if you know that, how many kids liked chips? That's one piece. How many kids on one piece? 3. So chips equals 3 kids. But now if I ask you, what fraction of the kids liked chips? Fraction, it must be something over something. How many parts do I have in the pie chart? I have 12 parts, so that's my denominator. How many kids liked chips? 3 kids, but that's one part of the pie. 1 over 12 liked chips, and that is equals to 3 kids. Apples. Well, apples I can see one part, 3 kids in here, 3 kids in there. So how many kids liked apples? 6 kids liked apples. What fraction of the kids? Fraction must be something over something. Numerator, denominator. Denominator stays the same, 12. How many parts do I have? 1, 2 parts. 2 out of 12. Now, if I have to write that as a fraction, I need to simplify it. Divided by 2, divided by 2. 1 over 6. Okay, so that's how you do pie charts. Let's move on to this side. Over here, the second part of the test, I'm going to give you these tables, and you have to find the rule. Now, the thing that you need to remember, the rule you always find from the top to the bottom. Okay, that part is very important. So if I try to find a rule, how do I get from a 3 to a 10? I can see 3 times nothing gives me 10. So it cannot only be 3 times something, because 3 times 3 gives me 9. Plus 1 gives me 10. So times 3 plus 1. That worked for that one. Let me see this one. 2 times 3 gives me 6. Plus 1 gives me 7. Okay, so it works there. Now it needs to work here too. 1 times 3 gives me 3. Plus 1 gives me 4. So now I immediately see, okay, that's my rule. My rule is times 3 plus 1. And now I have to apply that rule to the 5 to get the answer at C. 5 times 3 gives me 15, plus 1 gives me 16. So C is equal to 16. 10. I've got to do the same. I have to apply the rule to the 10. 10 times 3 gives me 30, plus 1 gives me 31. Okay, let me look at this one. Now over here, I've got to look, what do I have to do with the 2 to get to a 4? I can say, well, 2 plus 6 gives me 8. Okay, now if that is the rule, it needs to apply to this one too. What is 3 plus 6? That gives me 9. Okay, so this one didn't work, so I'm not going to use it. Let me try something else. Okay, I can always say 2 times 4 gives me 8 times 4. Okay, now I need to apply to this one. 3 times 4, yes, that gives me 12. 1 times 4, yes, that gives me 4. So that will be my rule. My rule will be times 4. Now, if I know my rule is times 4, I have to apply it to the 10. What is 10 times 4? 40. What is 100 times 4? 400. And that's why you need to know your tables. Very important. Okay, over here, I'm going to give you examples like this in the test. I will give you the rule this time. I'm going to say the rule is going to be times 5 minus 1. Now I have to apply it to the 1. 1 times 5 gives me 5, minus 1 gives me 4. 2 times 5 gives me 10, minus 1 gives me 9. 3 times 5, 15, minus 1, 14. 4 times 5, 20, minus 1, 19. 10 times 5, 50, minus 1, 49. Okay, and then we also have examples like this, where I will give you the spider type sums, where it will be 4 times 4, 16, 5